Hi, in this video what I'm going to do is I'm going to go through the examples that I went over in class, and I'm including the answers to these questions just in case you have the question right and you just want to move on to the next question. You're being asked two things here: state the excluded values and simplify. So the answer here in brackets is the restrictions on the domain. In other words, the value of a cannot equal 0, and we'll talk about that here in a second. But let's just look at these steps we're going to go through for simplifying. We'll go through this little flow chart every single time we do a question. First, we're going to factor both numerator and denominator. Next, we'll state any restrictions on the domain, and finally we can cancel out equal factors. And in this first one, it's a fairly simple question to start with because they're really they're just factors here. There's nothing to factor, so it's ready to just be simplified. And this is more of an Algebra 1 type question, but this will just get us started. Let's first start with going through this process. Again, we don't have to factor anything because we just have factors. So let's look at the restrictions on the domain. One thing we need to understand is that there is a number, it's undefined fraction, and it would be 1 over 0, or anything actually over 0 is undefined. So keep this in mind, that this is a fraction that does not exist. And you know, an example of that is remember that in a fraction the numerator is the part and the denominator is the whole. And if I don't have any, let's just say gum, how can I give you one part of that or any part of that? See, it is just something that doesn't exist, or it is impossible. So that's just an example of why that it does not exist. But let's just take a look now at this problem, because it says now we can cancel out equal factors. In this case, we have a fraction, negative 15 over 20, which can be reduced down to negative 3/4 because 5 is a factor of both of these. So we can cancel out the factor 5 in both, and when we do, we're going to have a 3 here and a 4 here. Next, we remember that when we're dividing powers, we actually subtract those exponents. And so we can get negative 3/4 a to the, excuse me, back that up, negative 3/4 a to the negative first. And again, we don't see that written like this in this answer, so let's just recall how to convert that back over. We know that if we have a to the negative first, and I'm just going to put it over the number 1 just so you can go along with this story if you recall in class. If you want to make this a happy exponent, you just move its position in the fraction. So if it's already in the numerator, if you want to make it happy, you're going to push it to the denominator, and vice versa. So all in all, that's why this answer equivalent is negative 3 over 4a. Let's look at the next question. In this problem, it looks like we are going to have to go through the steps, and we do need to factor the numerator. The denominator is already factored, but the numerator does need to be factored. So again, this is not a lesson on factoring, so I'm just going to quickly go through this. Factors of 9 that equal 6, or minus 3 minus 3. And now what we want to do is look at that second step here, state any restrictions on the domain. And the question is, what value of a would make this whole thing equal 0? It's very similar to finding zeros or roots of the function, so you should be able to figure that out, that a cannot equal 3. Next, we can cancel out equal factors. And I want to make note of the fact that factors don't mean terms. Factors mean groups that are the same. So you just got to be real careful when you are canceling out here. So those two can be canceled. They become 1s, and your final answer is a minus 3. Okay, let's do this one more time. Again, we're going to factor both the numerator and denominator. And then we will state the restrictions on the domain. Again, we have a situation where we can't allow a certain number to play in this problem because it would create the undefined fraction. So, and that number is the number 4. So or excuse me, negative 4. So b cannot equal negative 4. And that's where this comes from. Next, cancel out equal factors. So I'm going to go through here and cancel out the b plus 4s, and then I can reduce 2 fourths down to 1/2. And again, this will be the last question in this video, but notice we have, it's getting, like I said, it's getting more complex. What I'd like to do is just to take a look at that numerator, and we can see that there is a common factor of a p in each term. We also have a common numerical factor of 3. So the first thing I'll do is I will factor out 3p. And when I do, I'm going to get p squared minus 6p plus 5 over p squared minus 4p minus 5. And again, we got to continue this factoring process because everything has to be completely factored. So again, this is not a lesson on factoring. I'm just going to, again, just go through this fairly quick. Factors of 5. That equals 6. Well, 5 and 1, that has to be there to create the 5, but to get the negative 6, both of these will be negative. And down here, we have the same thing. The last two terms have to multiply to equal 5, but the combination here is we need to get a negative 4, so I'm going to make that negative and this positive. Okay, so now the second step is state any restrictions on the domain. Again, you can totally ignore the numerator because it's really just the denominator that can't equal 0. So the values of p that cannot necessarily play in this function because it would create that undefined fraction would be negative 1 and positive 5. All right, now we're ready to cancel out equal factors. So we can go ahead and cancel those two out, and really and truly that's all that we can cancel out, because they're not identical groups here. So again, I want to make that fact known, that just because you have an equal term doesn't mean you can just slash it out. They have to be equal groups when you have that plus and minus in there. An example of that is if you had 2 plus 3 over 2 plus 6, let's just say, and we know that's equal to 5/8, but we can't come along here and just cancel those out or cancel these out just because they've got common factors. This plus sign prohibits us from doing that because really and truly there's really some parentheses that should be wrapped around here, and you do what's inside the parentheses first before you start slashing away. So at any rate, that's an example why you can't just start canceling things out that look the same. And that concludes this video.